your goggles, your gloves, your lab coat, your closed toe shoes, and your mask.
The reactor tubing is high temperature and chemical resistance. Stirrer motor is mounted on the top of the reactor. For sodium hydroxide and ethyl acetate is provided beside the stirrer motor. The inlet piping has been converted into preheat coils with a certain number of water bath is used to control the temperature inside the reactor. An inlet and outlet line has been provided for the circulation of water into the reactor and water bath. Two feeding tanks provided for the reacting chemicals. Dosing pumps have been positioned beside the reactor hosing frame for feeding the fluid into the reactor tubing coil. Water bath temperature controller indicates the temperature inside. Power switch is used to turn on the equipment. TIC controller is used for the heating purpose, and steering switch is used to control the steering. Emergency stop button is used to stop the equipment in emergency case. Water filling button is used to fill the water bath. Alarm button is used if any accident happened when the equipment is running. The experiment name is plug flow tubular reactor. This experiment has two parts. The first one is preparation of calibration curve for conductivity versus conversion. In this part of the experiment, the reaction to be studied is the saponification reaction of ethyl acetate and sodium hydroxide. Since this is the second order reaction, the rate of the reaction depends on both concentration of ethyl acetate and sodium hydroxide. However, for analysis purpose, the reaction will be carried out by using equimolar feeds of ethyl acetate and sodium hydroxide solutions with the same initial concentrations. The procedure for this part of the experiment is quite similar with the batch liquid reactor. Therefore, you can use the data collected from the experiment of batch liquid reactor. Prepare solutions in the same way and record all data in the sample table in Appendix A and plot the calibration curve of conductivity versus conversion, determine the slope and y-axis intercept. The second part of the experiment is to determine the effects of residence time on the saponification of sodium hydroxide and ethyl acetate by using plug flow reactor. The objectives of the experiment are to carry out a saponification reaction between sodium hydroxide and ethyl acetate in a plug flow reactor. The second is to measure the conversion of ethyl acetate in saponification as a function of the design parameters in a PFR, plug flow reactor. And the third objective is to determine the reaction rate constant and the rate of reaction of saponification reaction in a PFR. And the fourth objective is to observe the effect of residence time on conversion of ethyl acetate. Before you start the experiment, you should know some safety considerations. Please read the manual carefully and follow the instructions. Always check and rectify any leaking. Do not touch the hard components of the unit. Be careful when handling any chemicals and wear the gloves. Do not operate heater in a dry condition. Shut down the unit after used. Stop the experiment and unit immediately when there is any accident happened. Start for the preparation of ethyl acetate solution. To prepare 10 liter of ethyl acetate, we need 98.91 ml of ethyl acetate. So here we have ethyl acetate. After measuring ethyl acetate, so we need to add 10 liter of distilled water to make ethyl acetate dilute and to prepare 10 liter of ethyl acetate solution. Fill with distilled water almost 6 to 7 liter, then add ethyl acetate.
water until the total volume of the solution becomes 10 liter. So we are adding more distilled water, so until the total volume becomes 10 liter. Ethyl acetate solution is ready now. Let's prepare sodium hydroxide solution. So we want to prepare 10 liter of 0.1 molar sodium hydroxide solution. So for this one we need 40 grams of sodium hydroxide. Take sodium hydroxide in the beaker, add some distilled water, dissolve it in the distilled water. Sodium hydroxide dissolved already in the distilled water, so now we will add this solution to add distilled water until the total volume of the solution becomes 10 liter. So before we start the equipment, we need to fill these solutions in the reactant tank 1 and reactant tank 2. It's sodium hydroxide in the reactant tank 1. Are not overfilled, so otherwise the solution will come out from the top of the. After filling the reactant tanks, put the cover back on the reactant tank. We are going to start our experiment, and before the starting of the equipment, make sure all the valves are closed. First step is to turn on the power of the equipment. Turn on the monitor. After that, open the water valve. To fill the water bath with water, turn on TIC control. After, press water filling button to fill up water bath. Bath tank is filled with water, then turn on the stirrer. So the temperature inside the reactant tank is set to 30 degrees Celsius. Here we have water bath temperature controller. So from here we can adjust. From the computer, open the software. After the software is open, click on the run button. Make sure there is no solution inside the cylindrical tubes, otherwise you may have the error in your readings. So for this purpose, we need to clean the cylindrical tube. First of all, we will open the air inlet valves. According to manual, this is valve 5. This one is valve 6. So we will open these two valves first. Then open air valve. This one is air regulator. Here you can check the air pressure. The pressure of the gas is around 0.2 megapascal, so it will be enough to remove the solution inside the cylindrical tubes. So now we can see there is no solution inside the cylindrical tubes. It's already clean. So first you need to close the air valve. And then close valve 5 and valve 6. For safety purpose, please don't forget to close these two valves. Okay, once you want to clean the tubes, please open first these two valves, then open the air valve. After all the tubes clean, then make sure you close the first air valve, not these two valves. After you will close the valve, then close these two valves. So from the software you can see here the flow rate for pump 1 and pump 2 we can control easily. So now after cleaning the tubes we will set the flow rate for both pumps 360 ml per minute to fill the cylindrical tubes again. Click on the flow rate area, so type 360 and press enter to start pump 1. At the same time enter the value for pump 2, that is 360 ml per minute, and press enter. After the tubes are filled, please stop both pumps by making the value 0. Now you can see some of big air bubbles inside the tubes, so we need to remove these air bubbles to make our reaction very smooth. For this purpose, set the flow rate for both pumps 200 ml per minute. After a few minutes you will see there is no air bubble, then we can stop both pumps. For this experiment, we will take the readings for 50 ml per minute flow rate, for 100, 150, 200 and 250 and 300. So here we will select 50. Press enter and then 50 for pump 2. Here we can set the time 60 seconds. So after each 60 seconds it will give us one reading. So now we are going to start record. So click on the start record button. So after 1 minute you will see one. Now you can see there is one reading already appeared. You need to wait until you will get 10 readings. So after you will get 10 readings, you will need to click on the stop record button. At the same time, you will stop both pumps by making the value 0 ml per minute for both pumps. After the pumps will be stopped, so here the button print, we will click on the print button so we can save the readings in the system. So the Excel sheet will appear. You will see the folder for Excel sheets. Here is the example of the 10 readings. Then to save the readings, click on the file option and then click save as, and then here you can give the file perform for 100 ml per minute, for 150, for 200, 250 and 300. You will get the separate table, so you will have 6 tables. Before record for the another flow rate, after you already save the reading for your desired flow rate, then please click on the reset. Before taking the value for 100 ml per minute, clean the cylindrical tubes inside the reactant tank. After you finish the experiment, you need to clean the tubes again. After you took all readings, just click on the stop button and then close the tap, and then transfer your recorded data to your DVD. Shut down the computer first. Computer is shut down, then turn off TIC control, stirrer, and then turn off power button. So please don't turn off the power button before you shut down the computer. In the end of the experiment, please make the reactant tank empty, so drain out all the water by opening drain valve. All the water inside the reactant tank will be drained. Once all the water is drained out, so please close the valve.